Hi students, welcome back. We're going to be talking about using and misusing references. We're going to start off by discussing copy constructors. So getting started. A copy constructor is a constructor with a single argument of the same type as a class. Copy constructors should create an object that is a separate, independent object, but with the instance variable set so that it is an exact copy of the argument type. So let's look at an example here to try to bring some clarity to that. So we're going to actually take a look back at our date class, which we've used previously. And here it is. Here's a date class. And this right here would be the example of the copy constructor. We have public date, and the parameter says date object a date. Now the copy constructor, or any other constructor really, creates a new object of the class date. Now this happens automatically, and it's not showing the code for the copy constructor. I'm not going to put comment lines in there or anything that says this is a copy constructor, simply because it's kind of self-explanatory and Java will handle it. Now the code for the copy constructor then goes on to set the instance variables equal to those of its one parameter, a date. But the new date created is a separate object, even though it represents the same date. So let's take a look at this copy constructors with a quick example. So consider the following code: date 1 equals new date, January 1st, 2015. Date 2 equals new date, date 1. Now if you look at that, you can see that date 2 is going to get the values of date 1. So they're both going to represent the date, January 1st, 2015. However, they are two different objects. They're not the same. Right? And so what will happen is if we change one of those objects, it's not going to change the other. So for example, if I say date2.setDate July 4th, 1776, and then I do a system.out.println of date 1, if you're expecting it to be July 4th, 1776, you're wrong, because it's actually going to remain as January 1st, 2015. Simply because I changed the value of date 2, but I did not change the value of date 1. So when we change date 2, we did not change date 1. As I already mentioned, this is not necessarily difficult or even a very subtle point, but it is critically important that we understand this because much of what we discuss in this section will affect the rest of the chapter. We've talked about references up to this point, and how objects can share memory addressing. The thing is, when you use a copy constructor, what that does, even though they have the same values, their space in memory is still different because they are two different objects. So let's look at another example here for the copy constructor for the class person, which is a little bit more complicated. So we have public person original. If original is not equal to null, or equals null, excuse me, I'll put a fatal error and then exit the system. Otherwise, we're going to do name is equal to original.name, born is equal to new date, original.born. If original is dead, and that's set to null, we're going to set died equals to null. Otherwise, died equals new date, original.died. So what we want is the object created to be an independent copy of the original. Now, this is not going to occur if we had used the following instead: public person original. If original equals null, system not fatal, system 0, that's all the same. But then we look down here, we have name equals original.name, born equals original.born, died equals original.died. Now that looks very similar to something that we've seen before, when we start using things like set methods. But we don't want to do that. Right? Although this alternative approach kind of looks innocent and may work fine in some situations, it does have some serious issues. Assume that we had used the unsafe version on the previous slide instead of the one that's in the class materials. The not good code simply copies references from original.born and original.died to the corresponding arguments of the object being created by the constructor. So the object is not an independent copy of the original object. So if we consider this code, person original equals new person, now address, new date, January 1st, 1984, common null, person copy was new person original, copied at set birth year 1800, system.out.println original. The output would be now April 1st, 1800 dash. Now, why would this occur? Well, when we change the birth year in the object copy, we also change the birth year in the object original. Remember what I just talked about with memory addressing? If you had used the bad method, what you're doing in effect is pointing the two objects to the same memory address. So they're really getting the same thing. So when you change the value for one, you're changing the value for the other one. So they're not really two separate objects. Even though they may share two different names, they're really in effect the same object. Now, this is because we've used the unsafe version of the copy constructor. Both original.born and copy.born contain the same reference to the date object. And lo and behold, as I said, it's using the same memory reference, which again is not a good thing to do. Now, this has all happened because we use the unsafe version. Fortunately, here we use a safe version of the copy constructor that sets the born instance variable as follows: born equals new date original.born, which is equivalent to this dot born equals new date original.born. Right. So this version which we did use makes the instance variable the set born an independent date object, which represents the same date as original.born. So if you change the date in the person object created by the copy constructor, you will not change that date in the original person object. Note that if a class such as a person has an instance variable class type, such as the instance variables in our case born and died, then to define a correct copy constructor for the class person, you must already have copy constructors for the class date of the instance variables. Right? So in other words, what they're saying is because this uses multiple classes, you have to make sure that you have copy constructors not only set up for person, but because it's using date, you need a copy constructor in date as well. Now, the easiest way to ensure this is for all your classes is to always include copy constructors in every class you define. So, up to this point, we've had constructor methods, we've had accessor, mutator methods. One of the things we want to start getting into now is making sure we start including copy constructors, simply because it's a good thinking, a good approach to be putting into our code. Now, real quick, I'm going to do this small segue here. Java documentation actually states to use a method in clone instead of a copy constructor, and there actually are situations where the copy constructor will not work as desired, and you will need to use the clone method. However, we do not yet have enough background to fully delve into this method, although it is discussed later in programming too. Now, despite Java's documentation, many excellent programs sometimes prefer to use copy constructors. Now, with that out of the way, let's quickly talk about one of the big pitfalls of copy constructors. The big thing is privacy leaks. So let's consider the accessor method get birth date for the class person. So public date, get birth date, return new date born. One thing you want to avoid is making the mistake of defining the access method as follows: public date, get birth date, return born. Notice it does not say new date, it just simply says return born. This is what's known as a leaking accessor method. Assume we use the unsafe version of get birth date instead of the one that's actually in the person class. It would then be possible for a program that uses the class person to change the private instance variable born to any date whatsoever and bypass the checks that are in the constructor and mutator methods of the class person. For example, consider the following code, which might appear in some program that uses the class person. Person citizen equals new person, Joe citizen, new date January 1st, 1900, new date January 1st, 1990. Date name equals citizen dot get birth date name dot set date April 1st 3000. Now this code will change the date of birth so it's after the date of death. So in other words, the person wasn't born until after they died, which doesn't make any logical sense. This sort of situation is what's known as a privacy leak, because it allows the program to circumvent the private modifier for an instance variable such as born, and to change the instance variable to really anything whatsoever. The following code that would then be illegal within our program: citizen.born.setDate April 1st 3000. So that little snippet right there was an illegal line of code. So why this is because illegal, because born was a private instance variable. Now, however, if we look at the unsafe version of get birth date, and now we're assuming that we did use the unsafe version rather than the safe version, the variable date name contains the same reference as citizen.born, and so the following is legal and equivalent to the illegal statement: date name.set date April 1st 3000. So that's legal, but it's also equivalent. This is all if we use the unsafe version of get birth date, which simply returns the reference in the private instance variable born. Again, notice we're talking about returning a reference, not necessarily a value. Fortunately, here we use a safer version of get birth date, which has the following return statement: return new date born. Because we also want to use the date call, we don't want to get the reference, we want to get the actual value. So that's why we have to use return new date. Now, this return statement does not return the reference in the private instance variable born. Instead, it uses the copy constructor to return a reference to a new object that is an exact copy of the object named by born. If the copy is changed, that has no effect on the date whose reference is in the instance variable born. Thus, a privacy leak is avoided. All right, now we've already discussed leaking access methods. Let's talk about leaking mutator methods because returning reference is not the only possible source of privacy leaks. A privacy leak can also arise from incorrectly defined constructor or mutator method. Notice the definition for the method set birth date in the class person and reproduce it below. Public void set birth date, new date, if consistent new date died, born equals new date, else system out of that line, inconsistent date is aborting, system x 0. You'll note that the instance variable born is set to a copy of the parameter new date. Suppose that instead of born equals new date, we use simply born equals new date. Suppose then we had the following code in some program. Person object equals new person, Josephine, comma, new date, January 1st, 2000, comma, null. Date name equals new date, February 2nd, 2002. Person object dot set birth date, date name, where person object names an object of the class person. The following would change the year part of the date object named by a born instance variable of the object person object, and will do so without going through the checks and mutator methods of our person. Date name dot set year 1000. Because date name contains the same reference as the private instance variable born of the object person object, changing the year part of date name changes the year part of the instance variable born of person object. Now, not only does this bypass the consistency checks in the mutator method set birth date, but it is also a likely source of an inadvertent change to the born instance variable. If we define set birth date as shown in the class materials for the person class, this problem does not occur. All right, and let's spiral right back to clone because we have one final word of warning here for you. Using copy constructors in this manner that we've been talking about is not officially sanctioned way to make copies of an object in Java. As I mentioned before, the authorized ways to find a method named clone. All right, and as I mentioned, that would be a concept for programming too. Right. From what we were doing until then, copy constructor will be a very adequate way of creating copies of an object. All right, and that's all, folks. Until next time.